Hello friends, welcome to Maths Nerd.
Today, I will show you how to solve linear equations in two variables using the substitution method. So today, we will see linear equations in two variables using the substitution method. So whether you are studying for your examination or just want to see how to do that, this is the perfect place. So to begin with, we will see an example like 2x plus 3y is equal to 7 and 8x plus 3 is equal to 19y. And remember, to solve a linear equation in two variables, you always need two equations with each containing variables. So suppose this is the equation or any other, then you have to take any one of the two and then convert it into the form of ax plus by is equal to c, where x and y are your variables while a and b and c are real numbers. Then you have to subtract by from both sides, so it is a by minus by is 0, so ax will be left on the LHS and c minus by on the RHS. Then divide both sides by a, so x is equal to c minus by upon a, and then plug in the value of x into equation number 2. So let's see this in action. So we'll take this same example. 2x plus 3y is equal to 7 and 8x plus 3 is equal to 19y. So to begin with, like I had done in the previous slide, I will subtract 3y from both sides and divide by 2. So x is equal to 7 minus 3y upon 2. And if you want to write this question in exam, then you must write the previous steps which I had done to get the full marks. So anyway, x is equal to 7 minus 3y upon 2. Now we'll plug in the values of x here. But first we need to write 8x plus 3 is equal to 19y, which is given to us already. So 8 into this represents the multiplication sign, 7 minus 3y divided by 2 plus 3 is equal to 19y from 1, as we are using this value here. So we need to cite a reference, and then this 2 and 8 will get cancelled, so it is 4 into 7 28, 4 into minus 3y, that is minus 12y, plus 3 is equal to 19y. So 28 minus 12y plus 3 is equal to 19y. 28 plus 3 is 31, 31 minus 12y is equal to 19y. And now we'll add 12y to both sides. So minus 12y plus 12y is 0, so 31 will be left on the LHS, while 19y plus 12y will be 31y, like this. So 31 is equal to 31y. Now we will divide both sides by 31. So 31 divided by 31 is equal to 31y divided by 31. So y is equal to 1, and we are again citing a reference so that we can use the value of y is equal to 1 to find the value of x. Let's see how. So first we'll write any one of the equations, the starting equations which was given to us. We can take any one, but since 2x plus 3y is equal to 7 is simpler, we'll take that. And then we'll put the value of y here. So 2x plus 3 into 1, this 3, and y is 1, so 3 into 1 is equal to 7. And we'll cite this reference from 2. So 3 into 1 is 3, so 2x plus 3 is equal to 7. We'll subtract 3 from both sides. So 3 minus 3 is 0, 2x left on the LHS, while 7 minus 3 is 4. So 2x is equal to 4. So we'll divide both sides by 2. 2x divided by 2 is equal to 4 divided by 2. So this 2 gets cancelled out, leaving x on the LHS and 2 on the RHS. So x is equal to 2, and our final answer is x is equal to 2 and y is equal to 1. Let's see one more example. So here the question becomes a bit complex. The root 2 times x is equal to the negative of root 3 times y. This is our equation number 1, and here the root symbol means the root of only 2, not x. And here the same implies, that is the radical symbol represents only the root of 3 times x, and Here also radical symbol represents the root of 8 times y. So the root of 3x is equal to the root of 8y. So first, instead of converting this into ax plus by is equal to c, we can directly divide both sides by root 2. So we'll get the value of x in terms of y like this. First we have this as given and then like this. So x is equal to minus 3y upon root 2, which is our equation 1, which we'll use later. So we are given that the root 3 times x is equal to root 8 times y. So we'll plug in the value of x, that is minus the negative of root 3 times y upon root 2. So we have root 3 into minus root 3y upon root 2 is equal to root 8y from 1, which is important. Then minus 3 minus root 3 into minus root 3 is minus 3, because root 3 into root 3 is 3 and minus 1 is minus root 3. So that is minus 3 times y divided by root 2 upon root 8 times y. And it looks like that we have reached a dead end, but we haven't, because uh, we can multiply this root 2 into 8y, but before that we should see how we can simplify this further. So we have root 3 minus 3 into y upon root 2 is equal to the root of 2 into 2 into 2, and here the under root is for all is for the three 2's but not y, that is essentially for the bracket. So 2 into 2 into 2 is 8, of course, but it is also 2 squared into 2. So the root of 2 squared is 2 and into the root of 2 into y. So we have root minus 3 upon y upon root 2 is equal to 2 times root 2 into y. So we'll multiply both sides by root 2, so it will cancel off from the denominator and it will come here in the RHS. So this 2 remains as it is here. Root 2 into root 2 is 2 and this y remains as it is. So minus 3y is equal to 4y, and this looks strange because it can be only true if there is one value of y 0. Let's see how we can prove it. So we'll subtract 4y from both sides. So on the right hand side 4y minus 4y is 0, while on the left hand side 3y minus 4y minus 3y minus 4y is minus 7y. So that's equal to 0, and you know that anything 0 divided by anything except 0 is 0. So we'll divide both sides by minus 7. So minus 7y upon minus 7 is y, and 0 divided by minus 7 is 0. So y is equal to 0, and we'll use the value of y to find the value of x. So we know that 3x is equal to 8y, which was given to us. So 3x is 0 because y is 0, so root of 8 into y is 0. So we'll divide both sides by root of 3. So anything divided by 0 divided by anything is 0 except that anything is not 0. So x is equal to 0, and we have found both the values of x and y, which are 0. Now let's see a word problem. In a recent RCB versus MI clash, the total runs scored were 276. That is, the runs scored by RCB plus the runs scored by MI were 276. If RCB won by 54 runs, who scored how many runs? So they are telling that RCB scored 54 runs more than MI, or the difference of the runs scored by RCB and MI was 54. So first let's convert this into algebraic terms. So let the runs scored by RCB be R and let the runs scored by MI be M. So in the equation 1 we have that the runs of their sums, the sum of their runs is 276, so R plus M is 276, and the difference of their runs is 54. R minus M is equal to 54 since R is greater here. And now we'll solve it like we did in the previous examples. So R is equal to 276 minus M, that we have derived that we have derived from here. We have subtracted m from both sides. So we have r is equal to 276 minus m, and we'll use this. But first we'll use the second equation, that is r minus m is equal to 54, and in that we'll plug in the value of r, that is 276 minus m. So 276 minus m is equal to 54. So minus m is minus 2m. So we have this equation like here, and then we'll add 2m to both sides. So here it will be just 276, and here it will be on the right hand side, it will be 54 plus 2m, and then we'll subtract 54 from both sides. So here it will be 2m, and here it will be 276 minus 54, like in this. So 276 minus 54 is 222. So 222 is equal to 2m. So we'll divide both sides by 2 because we want m to be isolated. So 2m divided by 2 is equal to 222 divided by 2. So m is equal to 111. So mi scored 111 runs. Now let's find how many RCB scored. So in the previous examples, for finding the second variable, I've always used either of the starter equations, but we can use the derived equations too. Since it is easy to use it here, we'll use that one. So r is equal to 276 minus m, but m is 111, that we know from here. So r is equal to 276 minus 111, so that is 165. So RCB scored 165 runs while MI scored 111 runs, and that's it.
Feel free to ask your doubts in the comments. Thank you for watching this video. Please like and share this video, and don't forget to subscribe my channel for more videos.